Okay, welcome to the lecture on Module 8.2, the IPv4 packet. The IPv4 packet is one of the primary network layer communication protocol. Its packet header is used to ensure that the packet is delivered to the next stop on the way to the destination. It definitely consists of various fields that kind of help you understand this. So let's take a look at what some of those fields and the headers are. Now in IPv4, and remember the binary field, all those values are binary. You have, it's 32 byte, so here you're seeing the size of it. So you got different fields. You got the version number, you got the internet header length, you've got the total length of package, identification, how long can this packet, so you don't want these packets to live out there forever. How long is it going to be? Which protocol? Is it IPv4, IPv6? Is the header correct? And then, of course, the two key ones is the source IP and the destination IP addresses. So the header is 20 bytes long and 40 bytes in length. 4 bytes only from the standpoint, what do you got? I got 32 bits. So it's a 32-bit, 20 bytes long. So let's get you a little bit. So the significant fields that you need to worry about is definitely the version. This version has a 4-bit field. If that field is set to 0100, it says it's an IPv4 packet. Keep that in mind. The differentiated services, or diffserv, the DS, used to be type of service, but the DS, it's an 8-bit field, determines the priority of the packet. The 6 most significant bits differentiate the service code point. The last 2 handle congestion notification. Is the network being slowed down some way to let everybody else know? The header checksum, it's used to check, has there been any corruption to the IPv4 header? So remember, it's only the 20 bytes in that header that it's worried about. The time to live, it's an 8-bit field that's used to limit the life of the packet. The source of, the source sets the initial value, and it's decreased each time the packet is processed by a router. If the TTL, the time to live packet, decreases to 0, the router discards the packet and sends an ICMP message that says time exceeded back to the source destination. Because the router decrements the TTL, the router must also recalculate the header checksum. Now, the protocol, it says, okay, which protocol is being used of the next level protocol. So this is an 8-bit field, and it indicates the type of payload the packet is carrying. It enables the network layer to, actually enables the router to discard packets, enables the network layer to pass on data appropriate to the upper layer protocols. Values could be ICMP1, it can be TCP, UDP. So it just depends on what is the next layer. What is the transport layer using in this process, or which application is being used? And then you got the source and destination IP address. Those are the 32-bit binary values. Now, there are some commonly referenced fields. You got the internet header length, the IHL, but they don't usually change much from header to not. Now, I would take a look at this video on IPv4 to see how to see them in Wireshark, because you are going to see this probably in a lab, probably someplace else. So just keep that in mind. So it'll go through and show that, and then you've got the understanding of that before. So short video. Some of the key things you want to keep in mind is the header fields and the characteristics of what the network layer, for at least for the IPv4, concerns itself with.